Welcome to another episode of Terry's Notes, and today we are going to be looking at coordinate geometry. So we'll be looking at the equation, the gradient of a line, the equation of a line, the midpoint of a line segment, and the length of a line segment. Okay, so let us talk a little bit about gradient. Now, whenever we have, let's say we have an XY axis and we have a straight line drawn. This straight line has a gradient which we call M, right, which is essentially the slope of the line. Now, if we have a horizontal line, the gradient or the slope is equal to 0. If we have a line that is sloping upwards, then the gradient is positive. If we have a line that is sloping this way, M is negative. And if we have a vertical line, M is equal to infinity, right? So if we have a line, let's say like this, and gradient M is equal to 2, and then we have another line which is even steeper, then M should be larger. So M could be something like 3. Right? So there is a formula to find the gradient of a straight line given or provided that we have 2 points on the line, right? So let's say we have a point A and another point which is B, and the coordinates of A is x1, y1, and the coordinates of B is x2, y2. Then the gradient is given by y2 minus y1 over x2 minus x1. Now you need to remember this formula, and just remember it's the difference of the y coordinates on top divided by the difference of the x coordinates at the bottom. So let's say, suppose A was 2, 6, and B was, let's say, 4, 12, right? And we wanted to find the gradient of the line AB. Then if we use the formula, M is equal to, right, now you see at this point here, whenever you have the two coordinates, you need to make sure you know in your head which one is x1, which one is y1, which one is x2, and which one is y2. So we can choose any one of the points and call it x1 or x2. So let's say I use A. Let's call this x1 and call this y1. If I need to call this x2 and call this y2, right? So what you can do when you have the coordinates, just put a quick label on top of the coordinates so you don't get confused. So it's y2 minus y1, so it'll be 12 minus 6 divided by 4 minus 2, and that gives me 6 over 2, which is equal to 3. So the gradient of the line AB will be equal to 3, right? Now, whenever you have a straight line, the equation of any straight line is of the general form y is equal to mx plus c, where m is a gradient and c is a coordinate, and it's the y y-intercept. Right? Now when we say y-intercept, what is the y-intercept? The y-intercept is the point at which a straight line crosses the y-axis. So this point here is the y-intercept, and the coordinate of that y-intercept will be 0, c. Okay, this is your origin here. So the coordinates of the y-intercept is always 0, c. Right? So the general form of the equation of a straight line is y is equal to mx plus c. So if you see an equation looking like, let's say y is equal to 2x plus 1, the gradient of this line is equal to 2, because the coefficient of x is 2, and the y-intercept is 0, 1, right? So the y-intercept is a point, therefore it has a coordinate, so it's 0, 1. If we have y is equal to minus 4x plus 2, then the gradient of this line is equal to minus 4, and the y-intercept is equal to 0, 2. Okay, so given any two coordinates of points on a straight line, we can find the equation of that straight line by first finding the gradient, which we already know how to find, which is y2 minus y1 over x2 minus x1, and then we have to get the equation in this form. So let's say we have, let's say a is 2, 7, and b is 4, 13, and we want to find the equation of the line AB. So the first thing we do, we find the gradient. So let's, for the coordinates of A, let's call this x1, y1, and let's call this x2, y2. Therefore the gradient will be equal to 13 minus 7 all over 4 minus 2. 13 minus 7 will give me 6, and 4 minus 2 is 2, so the gradient is 3. Now we haven't worked out the equation of the line as yet, we just worked out the gradient. So we know the general form of the equation of a line is equal to mx plus c. So we know what m is, we just worked out m as 3, so it's y equal 3x plus c. So we haven't worked out the equation completely, we still need to find what c is. So what you do, you choose any one of the 2 points, a or b. So let's say we choose a. So using a, we know that x is equal to 2 and y is equal to 7, right? I'm just using the coordinates of a. So therefore y, which is 7, is equal to 3 multiplied by x, which is 2, plus c. So what the coordinates of a is allowing me to do is to solve for c. So we have 7 is equal to 6 plus c, right? So 7 minus 6 is equal to c. So therefore 1 is equal to c, or c is equal to 1. So therefore the final answer, which is the equation of the straight line, will be y is equal to 3x plus 1. Okay, so we worked out the gradient using our formula for gradient, and then we worked out c by using any one of the points a or b into the general form of the equation, right? Now we can also find the midpoint of a line segment. which is also pretty straightforward. So if we have 2 points, A and B, and we wanted to find the midpoint, which is at the middle of the line segment AB. So we have M here, which is a midpoint, and this length is the same as this length. So what we're saying is that AM is equal to MB in terms of length, right? So M is directly in the middle of A and B. How do you get those coordinates? Well, it makes sense that the midpoint, to find the midpoint, we just add the 2x coordinates and divide by 2, and we add the 2y coordinates and divide by 2. But keep in mind that M is a coordinate. So look at how the equation is written. So let's say A is let's say 3, 7, and B is let's say 5, 9, and we want to find the midpoint of AB, right? If we use the formula just as it is, just if you don't want to remember x1 plus x2 over 2 comma y1 plus y2 over 2, let's remember we are adding the 2x coordinates and divide by 2, and we add in the 2y coordinates and divide by 2. So it'll be 3 plus 5. I'm just adding the x coordinates and divide it by 2. I'm going to add the y coordinates, 7 plus 9, and divide by 2. So this will be 5 and 3 is 8 over 2. 9 and 7 is 16 over 2. Therefore, the coordinates of the midpoint will be 8 divided by 2 is 4, and 16 divided by 2 is 8. Right? So this is how you find the midpoint of a line segment. Now, if we have a line segment again, and we have A and we have B, we can also be asked to find the length of the line segment AB. Now, this is just an application of Pythagoras' theorem, and what we are essentially doing is finding the lengths of this right angle triangle here. So if we are given the coordinates, we can find this length, and we can also find this length, and we just use Pythagoras' theorem to find the length AB. So if you look at the equation, which is here, you need to remember this, it looks very similar to Pythagoras' theorem, and this is a mistake. This is supposed to be plus, right? So let me give you an example. So let's say E is 2, 4, and B is 3, 6, right? So the length of the line segment AB will be the difference of the 2x values. So like I said, you need to label which one is x1. So x1, y1, x2, y2. Now I can tell you that this is very important. When I started maths a long time ago, this is what I used to do, right? So that I do not get confused. So you need to label x1, y1 and x2, y2, and you need to be consistent. So you cannot put x1, y2 here and then the reverse on the other side. Be very careful with that, because you can make a mistake very easily. Okay, so x2 minus x1, so this will be 3 minus 2 squared plus the difference in the y, which is 6 minus 4 squared, and we're going to find the square root of all of this. So 3 minus 2 is 1, so this is 1 squared, plus 6 minus 4 is 2, so this is 2 squared. Again, we find the square root, and this will be 1 plus 2 2's are 4, so this will be the square root of 5 units. And the reason why we are putting units is because we're finding the length of a line segment. Okay, so you can use a calculator and find the square root of 5, right, which would be 2 point something, or you can leave the answer as the square root of 5. Okay. Now let's talk a little bit about parallel and perpendicular lines. So what are parallel lines? Suppose we have two lines. This is A, B, and we have another line which is C, D. Now these two lines, A, B and C, D, are parallel, meaning that if we extend them to infinity, as in we keep drawing in this direction here, they will never meet. So parallel lines never meet, right, on a plane surface. So what do we need to know about parallel lines? If the gradient of one of them is let's say one of them is the gradient is 2, then the gradient of the other one must also be 2. So for parallel lines, they have the same gradient. So if one of them was a half, then the second one will also be a half. Right? Now, in the case of perpendicular lines now, so let's say we have a line AB, and we draw another line CD, and they are 90 degrees to each other, right? So they are right angles. So AB is perpendicular to CD, right? What can we say about the gradients? So if the gradient of AB is M1 and the gradient of CD is M2, the relationship between the two of them are as follows. The gradient of one multiplied by the gradient of the second one is equal to minus 1. So therefore, if one line, so let's say AB, the gradient was 2, and therefore the gradient of M2 has to be minus a half in order for us to get minus 1. So you can be given the gradient of one line and you will be asked to find the gradient of a line that is perpendicular to it, right? So let's say we have a line and they tell you that the gradient of one line is, let's say, 4. Then the gradient of the line that is perpendicular to that line will be, all you have to do is put a minus sign in front and invert the gradient, right? So the gradient of the other line will be minus a quarter. Okay, and we'll come to that question just now. A little thing you need to know as well, you can be given the equation of a line. Let's say y is equal to 4 minus 2x, and you want to know what is the gradient of the line. So just by looking at this line, the gradient has to be minus 2, right? Even though the general equation of a straight line is y equal mx plus c, you may be given an equation that looks a little strange. So you might see 2y plus x is equal to, let's say, 4, and you have to look at this line and figure out what the gradient is. So the first thing you have to do is to write this equation in the form y equal mx plus c. So we can write 2y is equal to minus x plus 4. All I did was move the x to the right hand side, and therefore y, you divide everything by 2, is equal to minus x over 2 plus 4 over 2, and this can be written as minus half x plus 2. So therefore the gradient of this line is equal to minus a half, right? So if you just look at this equation here, you can't just look at it and say, well, oh, the gradient is 1. You must write it in the form y is equal to mx plus c, which is what we did here, and then identify what is the gradient. Okay, So let me do another example. So if we have, let's say 2y minus 8x equal 1, and we want to find the gradient of this line. So we have to write it in the form y equal mx plus c. So 2y is equal to 8x plus 1. All I did was move the minus 8x to the right hand side. Then I need to divide everything by 2. So this will be 8x over 2 plus 1 over 2. Therefore y is equal to 4x plus a half. Alright, so the gradient in this case is 4. Right? So let's look at an example now. This is from the June 2012 paper, and they tell you a line passes through the points S, which is 6, 6, and the point T, which is 0, minus 2. And the first thing they want to find is the gradient of the line. So the first thing we need to do is to label our x1, y1, x2, y2. Now, I'm very serious about this. You need to label your points, please. In the exam paper, you can write x1 and y1, x2, y2. If you do that, then you will not make a mistake. All right? So the first part, find the gradient of the line. So we know gradient m. Let me do it on the side here. Gradient m is equal to difference in y, which is y2 minus y1 over x2 minus x1. Right? So just by looking at how we label it now, y2, which is minus 2, minus 6 all over 0 minus 6. Right? You see, if I label my points, there's no way I'll make a mistake when I substitute. Minus 2 minus 6 is minus 8, and 0 minus 6 is minus 6, and this will give me 4 over 3. So the gradient is 4 over 3. Right? The next thing they want now, what is the equation of the line? So we know the general equation of a line is y equal mx plus c. We already know the gradient. The gradient is 4 over 3. So therefore, y is equal to 4 over 3 x plus, sorry, this is c. Yeah? Y is equal to 4 over 3x plus c. So what we do, we take any one of the points. So I'm going to use t, right, because the numbers are smaller to work with. Right, so if I'm using a point t, we can say that y, so t is really 0 minus 2. What does this tell me? It tells me that when x is equal to 0, y is equal to minus 2. So therefore, minus 2 is equal to 4x over 3 plus c, which is minus 2. Sorry, what am I doing? Plus c. Right? So now what we should do is to get rid of this 3 at the bottom here. So we multiply everything by 3, and this will give me minus 6 is equal to 4. Sorry, I made a mistake here. This is 0. Right? So this will give me, sorry, I don't even need to do that. Leave this as minus 2, and this will be 0 plus c. Sorry about that. So therefore, minus 2 is equal to c. Alright, so therefore the equation of the line will be y is equal to 4 over 3 x minus 2. Right? So this is the answer for the first part. This is the final answer for the second part. That is the equation of the line. Now they want the midpoint of the line segment TS. So let me work out midpoint. So midpoint M is equal to, you have to add x1 plus x2 over 2, comma, y1 plus y2 over 2. So we're going to add the two x coordinates. So we'll put 6 plus 0 over 2, comma, and 6 plus minus 2 over 2, which will give me, this will be 6 over 3, comma 6 plus minus 2 is 4 over 2, and 6 divided by 3 is 2, and 4 divided by 2 is 2. So the midpoint is 2, 2. Okay, so that is the answer for third part. And then the last part, part 4, they want the length of the line segment TS. So first thing we do, we write down the formula for the line segment, which is x2 minus x1 squared plus y2 minus y1 squared, and we find the square root of all of this. And like I said, it's Pythagoras' theorem we're really using. So let's say, so it'll be 0 minus 6, right? Because I'm substituting exactly what x1 and x2 is, squared plus y2 minus y1, which is minus 2 minus 6 squared. Find the square root of that. So this is really 6. 0 minus 6 is minus 6, right? So it's minus 6 squared plus minus 2 minus 6 is minus 8 squared. Right? And this will give me 6 6 is at 36 plus 64. And it'll be square root of that. And this will be the square root of 100, which is equal to 10 units. Alright, so in this example, we applied all that we just learned: the gradient of a line, the equation of a line, the midpoint of a line segment, and the length of a line segment. Okay.